In this video, we're going to have a discussion regarding vernier calipers. And I have a little friend here with me to keep me company during the making of this video. And looking at the vernier caliper itself, these are slides. I'm going to open up the slides right here and expose the main scale. This part right here is called the main scale. Right here, I'm going to write that down, main scale. And if we were to take a closer look at the main scale, it is in fact, let's see where to go, here it is. This is in fact a ruler, just like this one. This is a steel rule. If we look at the main scale, I'm going to just increase magnification a little bit for the main scale. On the top, the main scale here is graduated in the imperial system for inches along the top, and on the bottom it's in metric, in millimeters. And if you look at a steel rule, it too has inches on one side, and this one here has millimeters on the opposite side of the metric system. For our purposes, we're going to stay with the millimeter scale, the metric system. And if we look at our steel rule, this one, the top part right here, is in millimeters. As you can see, it's in millimeters. And if I were to lay this rule on top of the main scale, well, the main scale is nothing more than a steel rule, or a ruler, if you will. And there it is there. Everything lines up in millimeters. So this main scale is nothing more than a steel rule, or a ruler. What the vernier caliper is, well, it has some attachments to it. I'm just going to reduce the magnification. So this is a steel ruler with some attachments to it. These are outside jaws, inside jaws, and here are some slides. On the slides here is another scale. I'm going to talk about those in a minute. And it also has a depth probe. So it is, in effect, a fancy ruler. So let's look at the main scale. And we're interested in the millimeters. I'm just going to close this up. I'm going to increase magnification a little bit so we can see each individual millimeter. So along the bottom, and we're only interested in the metric side, it is graduated in millimeters. This is called the discrimination of this instrument, or of this particular rule. The smallest division is 1 millimeter. From 0 to that first line is 1 millimeter. 2 millimeters, 3, 4, 5, 6, 7, 8, 9, 10 millimeters. So from 0 to here is 10 millimeters. And 10 millimeters is also same as 1 centimeter. And that's what that 1 represents, 1 centimeter. From 0 to here is 1 centimeter. But it's easier to read this vernier caliper using millimeters. So if we carry on, we have 10 millimeters, 11, 12, 13, 14, 15 millimeters, 16, 17, 18, 19, 20 millimeters. And above the 20, you see the number 2, which represents 2 centimeters. So we basically have 2 units, millimeters along the bottom right here, and the larger units here, which have numbers on them, they are in centimeters. I recommend stay in millimeters when we are reading this vernier caliper. And in the end, if we want centimeters, well, we'll simply do a conversion, and I'm going to do that later on. So let's have a look here at the millimeters. And our eye can resolve 1 millimeter. Between here and here, we can see 1 millimeter. I'm going to draw that here, that 0 to 1, and I'm going to make it a little bit bigger. So here's my 0, and here's my first division. And the distance between here and here is 1 millimeter. So all I'm doing, I'm taking that one little segment and showing it here. It's a little bit bigger so I can write on it. Now let's say I want to divide this into 10 more even segments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In reality, if I try to divide this into 10 more even segments, well, you won't be able to see it. Your eye won't be able to resolve those little itsy bitsy lines. I can do it here, so I'm just going to expand this. So here's my 1, my 0, and all the way over here, I'm going to take that 1. I'm going to just move it over here somewhere. In a moment, let me just draw some lines and see. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's that 10th one. So I've divided this into 10 even segments, and I've just made it bigger here. So that is shown here. So I have 0 there and 1 millimeter here. So I've basically expanded it. And those individual 10s are in here. And if I take 1 millimeter and I divide it into 10 even spaces, which I have done here, 1 divided by 10 then becomes 0.1. So this segment from here to there is 0.1 millimeters, 0.2, 0.4, 0.6, 0.8, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. I'm getting a little ahead of myself. I'm going to go into 2s next. So 0.1, 0.2, 3, 4, 5, 6, 7, 8, 9, and 1 millimeter. So each one of these segments then is 0.1 of a millimeter. If I were to take each one of these now and divide it into 10 again, 10 even little spaces, except instead of doing it 10, I'm going to put in 5 lines. I'm still going to divide it into 10, but I'm going to use 5 lines. So 1, 2, 3, 4, and this will be the 5th line. Yeah, 1, 2, 3, 4, that'll be the 5th line. So each one of these lines then, 0.1 divided with 5 lines, 0.1 divided by 5 will become 0.02. So each one of these lines then is 0.02 of a millimeter. 0.02, 0.04, 0.06, 0.08, 0.1. You forgive the spacing. And the same thing here. That'll be 0.1, 0.12, 0.14, 0.16, 0.18, and then 0.2. And again, I have 5 lines here. Each one is 0.2. Excuse me a moment. I was just double checking my math. 1 divided by, I should say 0.1 divided by 5 gives me 0.02. So each one of these segments has a value of 0.02 of a millimeter. So I'm dividing the original 1 millimeter into 50 segments. And each one of these here now, I can divide all of these into 1, 2, 3, 5 into 0.02s. The distance between here to here is 1 millimeter. And the individual lines, which I've divided into right here, is 0.02. And there are 50 of these lines going across. So there's 5 here, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So there will be 50 lines, or 50 segments. I haven't drawn them all in. All going all the way across, each one having a value of 0.02 of a millimeter. Oh, excuse me, there we go. 50 lines, each one having a value of 0.02 of a millimeter. And basically I'm dividing from 0 to 1 millimeter into as much finer segments. Now if I were to do this right here and divide that into 50 little lines, well, you can't see it at all. And that's where the genius of a gentleman by the name of Pierre Vernier at around 1631. He come up with a method such that we can resolve or see, when we divide this into 50 little segments, we can be able to see them. And that's what this is right here. This is his scale. And he did that right here. How this is done, the details of all of that, that's all written here in this text. And it's a separate course. Right here, Fundamentals of Metrology. And here is the Vernier instruments, named after Pierre Vernier. Here he is. And it says here, one of the simplest, the vernier, is a system of scales invented by Pierre Vernier in 1631. And you can see what it was he did. I won't go into the details of how he expanded this to come up with this scale. But here it is. So let's see, I'm just going to put that here. It needs to be tilted a little bit so you can see it. So I'm going to put something behind it. Maybe a pencil. I'm going to... And there is the Vernier scale. And from 0 all the way to the other 0, this is actually 1. This is nothing more than taking that 1 millimeter, which I just showed you, expanding it by a means of called amplification. This is Vernier's genius. Expanding that little bit and putting it here on this slide. So from here to here represents 1 millimeter. And he has divided that 1 millimeter into 0.02 of a millimeter. So if we were to count the number of lines that are here, we ought to get, well, let's see what we do get. Number of lines is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines, 20 lines, or 10, 15, 20, 25, 30, 35, 40, 45, 50 lines, just as I have shown you earlier. So there's 50 lines here. So that 1 millimeter right here is divided into 50 little segments. And each one of these lines has a value of 0.02 of a millimeter. So reading this scale, the Vernier scale, 0, 0.02, 0.04, 0.06, 0.08, 0.1. The point is not written on here, but that represents 0.1 millimeters. 0.12, 0.14, 0.16, 0.18, 0.2. And going across, again, the decimal place isn't written on here. It's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1 millimeter. And this is nothing more from each one of these segments divided into 50. By a means called, by Vernier, that he did, this is known as amplification. Such that we can see something really, really small and bring it up just like I'm doing here with my camera. This is called magnification that I'm doing with my camera. Actually, it's probably a version of magnification and amplification. But that's another story. So that here is the Vernier caliper. And let's make a measurement now with this Vernier caliper based on what we just learned. Let's measure something here. Let's see. Here we go. Let's measure a dime. And to measure something, we're going to put it between the outside jaws and use the flats of the jaws. Here, this flat surface. Don't want to use the knife edge. That's for another purpose. Get this dime. I'm going to put the dime in between the jaws. Notice I'm moving the slide here with my thumb. The slide here moves with my thumb. And I'm going to put here. Just simply going to place this down. And then magnify so we can do a reading. How big is that dime? We're going to count this in millimeters, starting at the 0. And we're counting all the way to the 0 on the Vernier scale. This is the Vernier scale. You want to count all divisions up to before the 0 on the Vernier scale, and in millimeters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 millimeters. 11, 12, 13, 14, 15, 16, 17, and I count this to be almost exactly 18 millimeters, where the 0 is. And to know if it is exactly 18 millimeters, and this has a little bit of what's known as parallax, and I'm going to call that exactly 18 millimeters. There's 10, 15, 16, 17, 18. That's where the 0 lines up. So this dime has a diameter of 18 millimeters. I'm going to bring this magnification down a bit, and let's measure something else. I have here an alien, and let's put that down here. So it's between the jaws, and let's have a look at, make this measurement. And this time I was very particular to make sure that it doesn't fall at an even number. So we can use the Vernier scale. Again, in millimeters, we want to count all the graduations in millimeters up to or before the 0. Looking at this one in millimeters, this is 10 millimeters, 20 millimeters, 21, and it's just before the 22. Now, so it's 21 and something, and that and something, the graduations in between the 21 and the 22 are here. On the Vernier scale, like I said earlier, this is the divisions of 1 millimeter. So it's 21 millimeters, plus I need to add to it this Vernier scale. So it's 21 millimeters. And where you have that 0, we're going to call that a decimal point. So it's 21 point. All of these then here are in the decimals. And that we want to find a line that completely lines up with the main scale. We want to find a line here on the Vernier scale that completely lines up with the main scale. And looking at this, I say, see, these don't line up. This one does almost perfectly. There's always a battle between one or the other. This one here, I would say it's that one. So that would be 0.7, 0.72, 0.74, 0.76, 8, 0.78, or maybe 0.8. I'm going to go with 0.78. Remember earlier, each one of these numbers is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and the smaller ones are 0.02, so that's 0.72, 0.74, 0.76, 0.78. Where they line up, I'm going to write down 0.78, 21.78, and I did everything in millimeters. To convert this now to centimeters, it's just a simple mathematical conversion. Multiply that. 1 centimeter is equal to 10 millimeters. Millimeters would cancel out, so 21.78 times 1 divided by 10. Divided by 10 is equal to 2.178 centimeters. We just move the decimal place over 1 in order to turn it into centimeters. And that is a crash course on reading a Vernier caliper.